This question is based on shaft. So a shaft is supported in bearing, which is kept 600 mm apart. It carries pulley, it's having a diameter of 500 mm, and it is placed at 250 mm to the right of left bearing. Okay, we have two bearings, left bearing and right bearing, and this pulley, which is having diameter 500 mm, is placed to the right of left bearing at a distance of 250 mm, and another pulley, which is having a diameter of 380 mm, which is placed at a distance of 130 mm to the right of right bearing. Okay, to the right of right bearing. These are the positions of the two pulley, and the belt drive in the left pulley is vertically downward. Some power has to be given for the pulley, right? That has to be transmitted to somewhere, and that belt direction is placed in vertically downward direction. While on the other pulley, I mean the pulley on the right side, is this power transmission is in the horizontal direction. Okay, so left pulley is having a power transmission along the vertical direction, while the right pulley is having a power transmission in the horizontal direction. Permissible shear stress is not to exceed 42 megapascal. So that means that is a maximum shear stress value, which is 42 megapascal, and the maximum tension in the small pulley is not to exceed 5500 Newton. Okay, I will tell what that value is later. And the coefficient friction, which is given as zero point 0.3, and angle of contact is 180 degree. You have to find the diameter of the shaft based on this condition. Okay, so let's look how to solve this problem. The figure, according to our condition, we have you see we have a bearing at point A and B. This is the position of pulley on the left side, and this is the position of the pulley on the right side. Okay, I have already mentioned the dimensions here based on the given condition of the question. And the diameter of the left pulley is 500, and the diameter of the pulley on the right is 380 mm. So this is the given figure, okay, given condition. So first thing first, we have to like write the given condition. For left pulley, we know the diameter is 500 mm. It's having a drive in vertical direction. That means the power transmitted is going in the vertical direction. And the right pulley, they already mentioned it's power transmission along the horizontal direction. Then I have written T3 as 5500 Newton. Okay, so maximum, I mean, based on the question, the maximum tension along the pulley on the right side is given as 5500, right? So when we are doing this type of question, say for example, we have two pulley. So obviously pulley works by, the difference in tension, right? There will be two tension, there will be a slack side and tight side. That means one side has more tension, other side has less tension. That is the basic working principle in which the power transmission happens in pulley. So we have two pulley. So each pulley has two tension, right? So I am taking the first pulley tension values T1, T2, and second pulley values T3 and T4. Based on this question, they have only given the tension or maximum tension or like tighten tension value of the second pulley. So already know I'm taking as, so you can take any like variable, but I'm using this convention as general. So I already know T3 and T4 as the tension of second pulley. I mean pulley on the right. So whenever we are taking for calculation, we will be taking the, I mean the first letter will be T3, right? T3, T4. The maximum value will be given for T3. As a general convention, will be doing to avoid a confusion. So among T3 and T4, we know we are normally like assuming considering convention as T3 as the maximum value. So already given that is 5500. So T3 is equal to 5500 Newton. You can take any letter, right? You can either put D1, D2, or if we follow this convention, it will be better to understand. So I'm taking T3 as 5500 Newton. So that's okay based on that value. So next, what they're given. Next, they're given like the theta, angle of contact. So angle of contact of both the pulleys is same. So I'm taking theta C and theta D as 180 degree. We only need the value in radian, not in degree. So we have to convert into radian at that time itself. So that will be 3.142 radian. And the coefficient friction is also given as 0.3. Then tau max. Okay, the maximum shear stress value they already given like it is not exceed 42 megapascal. So that means that's the maximum value of shear stress. So these are the all, I mean, all the given condition. So since we have only given the maximum shear stress value, this problem will be solved based on the SME equation for like maximum shear stress condition. That equation will be taken for solving this problem. Since we have only given the value of shear stress, so we'll be using that ASME code designed for. You can find it in the data book. The maximum shear stress theory, that equation will be taken to solve this problem. You will see that in the end of this problem. Okay. The the force diagram. We have to draw that in order to solve this problem. This is a left view of the our condition. This is a larger gear. Sorry, not gear. Larger pulley C that is drawn in the outer part. And inner part is dotted line because when you look in from the left side, you cannot see the right pulley. So that is why it is in dotted part. So I am taking the tension along the first one. The larger pulley is T1 and T2. I already told. And second one is T3 and T4. That's why it's drawn like this. They already told the first pulley is having a drive or power transmission in the vertical direction, especially in downwards. So that's why I drawn the two tension T1 and T2 in downward direction. While the other one, they haven't mentioned direction, but I'm taking in this direction, this T3 and T4. Okay, they already mentioned in the horizontal direction. So, in order to solve this type of problem, we have to separately consider the vertical diagram and the horizontal load diagram. That's a general way to do this. So, when we're taking the vertical diagram, we take at the point A, we know at point A it is a bearing. So the bearing point, just keep that in mind. It will having the reaction, both horizontal and vertical component of reaction. Okay, that's a fact we have to keep in mind. So at point A, since we are considering the vertical diagram, I'm only writing it as RAB. Okay, we are only considering the vertical component of the reaction. Same case at the point B is also having a bearing. Obviously, it also has a vertical component of reaction, so RBV. Then what are the forces acting in the vertical downward direction? We can see from this figure T3 and T4 is in horizontal direction, so we cannot take that. But T1 and T2 are in the vertical direction. Okay, so T1 and T2 are in the vertical direction. So net force, we can say there's a T1 and T2 acting downwards. So, and that is for pulley C. So at that exact point of pulley C, we'll be writing T1 plus T2, not T1 minus T2. Since we are considering the force diagram, we have to take the net force. So you have to write it as T1 plus T2. So these are the only forces when you're considering the vertical part. Next, we have to consider the horizontal load diagram. I already told there's a horizontal component for reaction as well. So obviously there will be RAH and RBH. We know that. So when we take in the horizontal load diagram, there will not be any tension for pulley C because it has it is only in the vertical direction. But for the second gear D, it has a horizontal direction. Load in horizontal direction, right? Tension. So you have to put the net tension. You have to mention that it is T3 plus T4. Okay. So I'm taking it as in downward direction. You can take in any direction, you will get the answer negative. That's the only difference. So T3 plus T4, I'm taking it as downward direction. This is the first step. So now you have to find all the tension value. That's the first step in solving this type of problem. We have to find all the tension value. So first we'll be considering the right pulley instead of left pulley because we have one known value. Why? They have given the value of T3. Maximum tension in the right pulley they have given. So we have a known value. So we will start from the right pulley. Okay. So say if in the question if it is given a known value of left pulley, you have to start with the left pulley. So here we are given the known value of right pulley. That's the reason why I'm starting with the right pulley. So consider the right pulley. Uh, you see there's a relation T3 by T4 is equal to e raised to mu theta. This relation you can find in the data book. You can find the data book. So that's a general relation we'll be using in case of pulley. Tension ratio. So you know the value of T3. From that you can find T4. Then we're taking the torque of the pulley alone. The torque on the right pulley will be due to the force difference. Tension difference of the two tension, right? T3 and T4. One tension will be higher. I mean, this will be more on the tight side and less on the slack side. There is a tension difference which causing a torque on the pulley itself. So TR is equal to T3 minus T4 into the radius of that pulley. So RD. Since we are considering the right pulley, that's RD. So that's a way to find a torque on a pulley itself. Okay. We have torque is basically force into that perpendicular distance along the axis. That force is created due to the tension difference here. That's why T3 minus T4. So we know the torque on the right pulley. So whenever doing this type of problem, we are assuming the torque on both the pulleys are to be same. Okay, since say for I have another pulley on the same shaft, we are considering both the pulley to be having the same torque. So same way we will be doing this problem, assuming torque on both the pulleys are equal. So torque on the right and I mean one on the left are both the same. So with this value, we will be finding the parameters of the left pulley. Okay, that's the way to solve this problem. That's the reason why I tell to start this problem by taking the right pulley. On the left pulley, we'll be doing the same way. Only these two set of equation will be using. So to find the torque on the left pulley, same way is due to the tension difference into that force into the radius of that pulley. Since we don't know the either of the value, but we know DC, right? We are assuming the torque on both the pulley to be same. So by using that, we can find the value T2. Also, we know this equation T1 by T2. This ratio can be applied to any pulley condition having two tension, right? So same way you can find the relation between T1 and T2 that can be substituted into the equation. From that, we can find the value of T1 and T2. So now we have four tension T1, T2, T3, and T4. This is the first step in the to solving this type of problem. Find the maximum bending momentum. We only need to find torque T and maximum bending momentum M. From there, we can use substitute in the final equation. That's the main. That's the way to solve this problem. So how do we find the maximum bending moment? Okay. So for that, we'll be taking by part and part by part. First, we'll be considering the vertical part. Then we'll be taking the horizontal part. From there, you will be finding the maximum bending moment. Okay. So taking the vertical part. I mean, if you're taking the vertical part, if you look at that load diagram, we can see the moment at I mean MAV and MBV will be zero, right? Because that 2 points are hinged point or pairing point, there will not be any moment at that point itself. We know that. So MAV equal to and MBV equal to 0. But we can use this equation to find the unknown value. So we can take any conditions. I'm taking MAV equal to 0, considering point A. We know taking moment at that point. Our BV into 600 that will be in the anti-clockwise direction, but the T1 plus T2 into 250 is in that will be in the clockwise direction at the point A. So obviously that should be in the opposite sides of the equation. So by taking the moment at the equating to be 0, you can find RBV. Other thing we know that the force will be equilibrium, right? These are equilibrium condition. Moment at that point will also be in 0 and the force will be also will be in equilibrium. So we taking the force equilibrium, that means force on the upward direction is equal to force on the downward direction. That means RAV plus RBV equal to sum of T1 plus T2, right? Simply the force equilibrium equation. So from that you can find RAV. Now we have the value of RBV and RAV. So what's the need to find RAV and RBV? Used to find momentum. Okay. So we also know that the moment along dv will be 0. Why? Because no force is causing the moment at that point. We have a pulley at that point. Even though there is no bearing point at that point, there is no force is in the force influence at that point d. So obviously mdv will be 0. The only moment that will be acting at the point cv. Okay, the point cv will be I mean that will be only due to the force RAV. Because RAV is near to the point C and that is the only force that is causing any chance of moment at the point C. No other force, no RBV is not RBV is not causing any type of moment at point C because RAV is near to C, right? So that's the way to take the moment. MDV will be 0 because there is no force causing moment at that point. But you can see since RAV at the end part is causing an like there will be bend due to RAV at the point C. So I have to find not to find MCV, that will be RAV into 250. That so you will get the value of moment at the CV. Okay, the only point that having moment is at the point C. So now we have the vertical component of the point at the C. Okay. So considering the horizontal loading, same way we can do it. We know MAH will be 0. There's no moment at the point A, there is no force influence. So obviously MAH will be 0. So by using the relation, you can find RBH. Okay, at that point, the moment about that point A will be 0. So you can use that equation to find RBH. Also, we know the force equilibrium condition. Okay, the upward force equal downward force. From that, you get RAH as minus 1656. Okay, so you can take the direction any direction. So if you get negative, you should understand that the actual direction was meant to be in the opposite direction. Okay, so now we have RAH and RBH. Next, we have to find the moment at that point, right? We know that MAH and MDH, I mean point A and D, the moment will be 0. But there is moment at point C and B. If you're considering the horizontal diagram. Why? At point C, it is due to the reaction force, that RAH, okay, that vertical, horizontal component of RAH, it is causing a moment at point C. That is the reason for causing moment at the point C. For point B, there's a T3 plus T4 in the downward direction because N force, if you imagine it that T3 plus T4 is acting downwards, which is causing like a bending about that point. So obviously it will have some moment influence at the point B. So when we're taking the horizontal part, MCH and MBH is present because for MCH it is due to RH and MBH it's due to T3 plus T4. So you can find MCH and MBH. Okay. So taking horizontal direction, there is a horizontal component at the point C and horizontal component at point B. Okay. Now we have to find the resultant moment. So we now need to find the resultant moment at point C and point B because we have a horizontal and vertical component at both the points. So we need to find separately the moment at the C. So this equation to find the moment, square root of A square plus B square form, normal resultant equation. So not to find the moment at point C, that will be square root of M square CV plus M square CH, right? In the case of C, we have both the value of CV and CH. So obviously we can find the value of MC. While taking the moment about the resultant moment at B, you don't have the value of like BV. So we know MBV is 0 for point B, but we have the value MBA. So we can find the resultant moment at the point B. So now we have both the resultant moment at point C and B. That means only these 2 points have the some moment, right? So you have the total moment at this point. So among these, we have to consider because based on the equation here, this is the equation, HME equation for maximum shear stress condition. Okay, this is maximum shear stress theory. This is the equation. So in this equation, you can only put all the maximum value. So this M, which has to be maximum moment. So among the moment at points A and B, take the maximum value that will be at the point B. So that M value should be substituted in this equation. So CM and CT, this is a fatigue loading factors and the dorsal loading factor. This is a constant we have to learn. CM as 1.5 and CT as 1. So remaining part you just have to substitute in the equation. So we will get the value of DS 58.14, but we cannot take that value. There is a standard table value in the data book. So based on that, the next standard value will be 63 mm. So that is the diameter of the shaft based on this condition.